Hello everyone. Today we will study about weightlessness. We know that we feel weight due to the normal reaction of the surface wherever we are standing. So if the normal reaction becomes zero due to the surface, then we say that the apparent weight is zero. So in that case, we will feel weightlessness. So what is weightlessness? Let's define in short. So when the normal reaction due to the surface then the apparent weight is zero. This condition is called weightlessness. So where do we feel weightless? The first case you have studied in Newton's laws of motion, the case of a lift. So first is in a lift. So let's recall the case of the lift. The person standing inside the lift, the weight acting downwards. Normal reaction always acts normally outward to the surface. And when this lift is moving down with an acceleration is equal to g. Just recall the case when the string of lift breaks. This is the case which you had studied. So that means when the acceleration of the lift is equal to acceleration due to gravity, then what will happen? How to write this equation? Just recall. We know by Newton's second law, net force is equal to mass into acceleration. Now this is moving down. So we will write net force is mg minus r is equal to ma. Now let's put the value of acceleration and shift normal reaction on the other side. So this will be mg minus ma, and therefore r is equal to mg minus mg. Therefore r is equal to 0. Here why we have written this? Because acceleration is equal to acceleration due to gravity, and this is the condition of weightlessness. So this was the first case. Let's take the second case. You are familiar with the spacecraft situation. So let's draw that. In a spacecraft, we know that the spacecraft is moving in an orbit around the Earth. So this is your Earth and this is your spacecraft. So let's say this is the spacecraft. And in this spacecraft, suppose this is the person. Obviously, the normal reaction will be normally outward to the surface, and this is the gravitational pull, right? So if suppose, because this has a tendency to fall towards the earth, so we can say that the acceleration, in case any, will be this. But in case this is acted upon by this acceleration due to gravity, we will write it this. So let's use the Newton's second law again. What will we write? Force of gravitation minus normal reaction is equal to mass into acceleration. So what will we write? G m upon r square minus r is equal to m into g, and this I will write g m upon r square. So from here r comes out to be 0. Why so? Let me write it. G m upon r square minus g m upon r square. This gives normal reaction is equal to 0. That's why there is weightlessness in the spacecraft. So these are the two major cases. Third case we can recall at the center of the earth. So at the center of the earth, recall the formula of gravitational acceleration at depth. So at the center of earth, the gravitational acceleration is g at surface into 1 minus d upon r, right? So this will be at center, the depth is equal to radius. That means this is the earth, this is the radius, and this will be the depth, same depth. So what will be the gravitational acceleration at depth? This will be g into 1 minus r upon r, and this gives g into 1 minus 1, and that means g at depth is 0. So weight at depth is equal to m into g at depth. That means at center, mass into g at center. So this will be m into 0. That means weightlessness, right? And at some places in the space, if the net gravitational force of all the planets and the heavenly bodies around it is 0, those points are also the places where weightlessness will be there, and those points are called as null points or neutral points. So fourth, I'll just mention here null points, the points in space where net gravitational force is 0. Now we can take another case. We can discuss the pendulum case. That time period of a pendulum This is given by 2 pi under root of L upon G, right? So where L is the effective length of the pendulum and G is the gravitational acceleration. So at the center of Earth, G is 0. So time period will be infinity. That means the pendulum will not oscillate, right? So this was all about weightlessness. That's all for now, and have a nice day.